Hi students, I just want to go over a couple problems from 12.4, which is exponential growth and decay, and highlight the important things there. Hopefully you'll be able to do these problems in my math lab, no problem, once you've seen this video. All right, so 12.4, exponential growth and decay. They each have their own formulas, they're only slightly different. So here we've got exponential growth. Basically, you start with an initial amount. All right, so this C represents the initial amount. And then that's going to get multiplied by 1 plus the growth rate, but your growth rate has to be as a decimal, okay? And the 1 plus the growth rate gets raised to the power of time. So T is time, okay? So you have to know how long it's growing for, T, its growth rate as a decimal. So say it grows at 10% a year as a decimal, that's 0.1, and the initial amount you have, okay? When you plug this into this formula, that will give you the amount you end up with after this amount of time, okay? That's exponential growth. The exponential decay is very similar, except that rate of decay, we want it to decrease. So exponential decay, we do the same thing. The amount we start with gets multiplied by 1 minus the decay rate raised to the power of T. So you can imagine over here with exponential growth, we're growing at 10%. Then 1 plus 10% as a decimal is 1 plus 0.1. So this number is bigger than 1, so we've got a base just bigger than 1, raised to an exponent, that's going to grow. Over here, 1 minus some decimal, that's a number between 1 and 0, so that's going to decay. All right, so those are the two formulas for exponential growth and exponential decay. The big thing you have to be careful of when you're reading these word problems is that the time and the rate have to be in the same units. All right, we've had stuff like this before. The time is, 6 months, and the rate is in years. Well, then you have to convert that time into half of a year, okay, so that they get into the same units, okay? All right, so let's take a look at an example. Let's say that Garfield High School has about 300 students right now, but the enrollment at Garfield High School is increasing by 10% a year, okay? And we want to know how many students are going to be at Garfield High School in 5 years, okay? This is an exponential growth rate. So we know that our current amount of students is 300. And if we're increasing by 10% each year, that's 0.1 as a decimal. And we want to know how many students we're going to have in 5 years. So that is our time. All right. So we'll plug this into that formula we had before. 300 is our initial amount. 1 plus 0.1, our growth rate, raised to the power of our time, 5. Okay. Now this whole thing simplifies. 1.1 to the 5th. And you can use your calculator on this section if you would like. Okay. To the 5th. That simplifies to 300 times 1.61, which simplifies to about 483 students. Okay. So that Y is our final amount. And so we know that our final amount is 483 students. So we started with 300. We grew at 10% a year for 5 years, and we ended up with 483 students. Okay. That is Exponential growth. You want to be careful to not say, well, 10% of 300 is 30, so I'm just going to multiply 30 by 5 years. That's not how it works, because the first year we grow by 30, but then after 1 year, our population is now 330, so we have to grow by 10% of that. And then after the year 2, our population is, bigger every year, so each year it multiplies by more. Okay, that's exponential growth. All right, let's do another example of exponential decay. So in this example, we have a basketball tournament that is sudden death elimination. And what that means is you play a game, 2 teams play a game, the team that loses is eliminated. So after each round, half the teams get eliminated. So we want to know if we start with 16 teams, so our initial amount is going to be 16 teams, how many teams are going to be left after 3 rounds? So our time here is in rounds, 3 rounds, and our rate is going to be 1/2. Okay. So you can probably do this one in a different way, but let's use the formula to calculate this. We start with 16 teams, our initial amount. That's going to get multiplied by 1 minus the decay rate. The decay rate is 1/2, raised to the power of the time. And we've got 3 rounds as our time. Okay. So when we simplify this guy, we end up with 2. So after 3 rounds, we only have 2 teams left. We'll play that 4th round and the game will be over, or the tournament will be over. Okay, so that's an example of exponential decay. Check your textbook for more examples and email me if you have questions.